Birds of a Feather, led by Justin Drake. Justin Drake is a researcher at the Ethereum Foundation, doing applied crypto, etc. So, Justin, you're up.
Hello, can you hear me?
Yes.
Yeah.
Great, awesome. So I was told this was a community Q&A, so I guess you guys need to ask me questions. I haven't prepared any talk. I mean, would it make sense for, I guess, people to either ask questions in the chat or maybe turn on your video and kind of, or your microphone and just ask questions? Okay, first question. Why burn the money in EIP 1559 and not spread it to the next X miners? Right, so I guess one of the things that we've tried to do is make sure that the issuance alone is enough to secure the beacon chain. And so if we were to take EIP, the proceeds of EIP 1559 and give them to the miners, then if that was true, then we'd be overpaying for security. I guess one of the reasons why we want to make sure that the issuance alone is sufficient to pay for security is that the proceeds of EIP 1559 are going to be volatile. So even if you smooth them out, right, over the next X blocks, it's still a very volatile market over the long term. And so even though it would provide an incremental boost to security, it wouldn't be very predictable. And so what we wanted to have really is this predictable, guaranteed security, and the best way to achieve that is with issuance, basically. But, I think potentially this idea of having EIP 1559 and spreading the proceeds to the next X miners makes a ton of sense for Bitcoin, right? Because Bitcoin's philosophy is zero issuance. And if they don't do this, the spreading of the MEV, then or I should say of the proceeds of the base fees, then they're in a position where they're even more exposed to these spikes. So this is something that makes sense for Bitcoin because they don't want guaranteed security; they want guaranteed scarcity. But we don't think that guaranteed scarcity makes sense if you don't have guaranteed security. I remember reading that for proof-of-stake rewards, the reward yield will try to target a percentage of ETH to be staked. E.g., if 10K ETH is staked, the yield will be 10%. If 100K ETH is staked, the yield will be 1%, deterring future stakers. So you're right, there is a curve. And you're right that the more people are staking, the lower the rewards from the issuance will be. The way that the curve works is quadratic. So basically, whenever you quadruple the number of validators staking, the rewards half. So the total amount of issuance is going to grow with the number of validators, but it's not going to grow linearly. So it's not going to grow as fast. It's only going to grow kind of square root of the number of validators. And one of the reasons here is to try and achieve an equilibrium and find kind of a fair rate to be paying for security. Is that true? And if a wrapped staked ETH becomes popular, would that undermine it? So some people believe that staked ETH is going to become maximally popular in the sense that almost all ETH will be staked ETH because there's no reason to not be staking ETH. And I think that's that's not going to happen. And one of the main reasons is that when you have staked ETH, there's something at risk, and that means that staked ETH can't really be a hard collateral asset, right? So in DeFi, you want this really strong money as your collateral, and you want it to have this guaranteed value. Unfortunately, with staked ETH, there's a possibility through slashing that the value goes from 1 to 0, like the value is completely wiped out from one moment to another. And so as such, I don't think staked ETH can be a good collateralization asset. So like if you look at Maker, for example, they try to set these collateralization ratios, but that only works. That will only work for staked ETH if there was a floor. For example, at most the staked ETH could lose half its value, but that's not the case. The staked ETH can lose 100% of its value. So I don't see actually staked ETH as becoming a strong collateral asset in the context of DeFi. How will ETH2 withdrawals be organized? Okay, so we want to enable withdrawals after the merge, and the reason why we're not enabling withdrawals at the merge is because we want to do this minimum viable merge as soon as possible. But after the merge, one of the first features that we do want to enable is withdrawals. In order to withdraw, you need to stop being a validator, so you need to exit. The process of exiting means going through the exit queue, which could take some time depending on how full the queue is. And then once you're exited, you become called withdrawable, meaning that you can sign a message with your withdrawal key, which is kept in cold storage, and broadcast that message to on the beacon chain, and the message will basically trigger a corresponding withdrawal back to Ethereum 1, basically back to the EVM. So like right now, there's kind of two ways to specify a withdrawal address or withdrawal credentials. You can either use a BLS signature to kind of authorize the process of withdrawing, or you could specify an ETH1 address, which is kind of the recipient address for your withdrawals. So that allows, for example, to make a withdrawal to a specific smart contract, and that unlocks things like decentralized trustless pooled staking. Can you talk a bit more about VTFs? I recall a key ceremony being mentioned a while back. Is this still a requirement? Right, so as Vitalik said, there's various ways to build VTFs. One of the possible ways to do that is using a group of unknown order. And one of the groups of unknown orders that we were very seriously looking at was an RSA group. Now, the problem with an RSA group is that you need this trusted setup in order to have a group of unknown order, which is truly unknown, where the order is truly unknown. Unfortunately, we tried really hard to make this this trusted setup work, but we at the point of doing the deep security due diligence. So we had these academic papers which got peer reviewed, which got accepted to conferences. We wrote a bunch of code, but we hired kind of an external team led by Zengo, which is one of the wallet providers that specializes in MPC. And during this due diligence process, we found a kind of a critical cryptographic flaw in the design of the most promising MPC to generate an RSA modulus. And so that kind of put spanners in this specific construction of VDFs based on RSA groups. The other construction that we're now looking at does not involve groups of unknown order, and it has various other advantages. And the way that it's built is basically using Sloth with a snark on top of it. So what is Sloth? Sloth is a kind of a proto VDF in the sense that it takes time to compute the VDF in one direction, and it's significantly faster to compute it in the other direction. But unfortunately, the speed up in the other direction is only constant, something like 100 times faster. But that's still a good start. And the reason it's a good start is that this constant time speed up in the other direction gives us enough breathing room for the overhead of the very expensive machinery of Starks, and of Snarks, I should say, to kind of allow us to have a fully Starked proof of the other direction, if that makes sense. So we have this base layer proto VDF, which we amplify to a full VDF using Snarks. So that's kind of the state of the art. And in a few days or maybe a few weeks, we should be making a big announcement on basically trying to bring this project to production with various partners, but that will be announced quite soon. Isn't the notion of minimal sufficient security spend inherently subjective? How is it measured? Does this introduce a point of failure and political risk? Okay, that is a good question. So the way that you can measure security is so basically the way that I use to measure security is what I call economic security. And the really, really nice thing is that for proof of stake, it's much easier to measure this economic security versus proof of work. So what is economic security? It's basically the amount of resources in dollars that is currently securing a blockchain. So if you look at Ethereum today, there's about 6.4 million ETH that is securing the beacon chain, and that's about $15 billion. And you can try and make a similar computation for Bitcoin. So for example, on Bitcoin, there's about 100 million terahashes per second. And purchasing and deploying these, like 1 terahash might cost you, $30, $40. I mean, it depends who you are. If you're Bitmain, you get a discount, versus if you're buying from Bitmain and things like that. But, you can try to put a dollar number on the amount of security. So it turns out that for Bitcoin as kind of a conservative upper bound, the economic security is roughly $10 billion. And for Ethereum today, it's $15 billion. Now, like one of the things that we can try and do is basically look at past behavior. Bitcoin is a much larger system, and there's only $10 billion securing it. Does that mean that $15 billion of security is too much? I mean, one of the goals for Ethereum is to try and be World War III resistant. So we'd rather be in a position where we overspend for security than unspend. And one of the things that we've done is that we've tried to calibrate the amount of issuance such that even in kind of an extreme case where, for example, there's 33.5 million ETH staking, so that's a million validators, 2 to 20 validators staking, the amount of issuance is less than 1 million ETH. So we want to try and find a good balance between security and issuance. I think as a community, we're happy with this 1 million ETH issuance, which is less than 1% increase in the supply. And with that kind of hard cap in mind in terms of issuance, today we have $15 billion of security, but in the future I expect that to grow, tremendously on the order of 100 billion, $1 trillion. And if the goal really is World War III grade security, then we need to consider state actors as our enemies. And it's definitely possible for a state actor like the US or China to put forward a budget of $100 billion to try and break Ethereum if it is really the substrate for the internet of value. And so this is something that we're going to have to keep an eye on and see how it progresses. But I'm actually expecting a very significant a portion of all ETH to be staking, something like 20-30%. And part of the reason is because besides the issuance, there's also going to be the MEV, which is not burnt. And Ethereum has this extra really nice property, which is that even if it does get attacked, it has a healing mechanism, and this healing mechanism is basically based on slashing. So if we do get attacked, we have this cancer, but we have a way of removing the cancer and healing ourselves. On the other hand, as Vitalik mentioned, if an attacker attacks Bitcoin with a 51% attack, this cancer can be a terminal cancer, like something that cannot be removed, and it will kind of kill the organism. Anyway, that's kind of a bit of a rambling question, but rambling answer, but it is an interesting question. What are your thoughts on the TrueBit project? So I think one of the things that TrueBit did is they basically took Wasm, which is a very interesting virtual machine, and built all the fraud-proof infrastructure so that you can make statements about Wasm. So for example, you could say, I have this Wasm program and this input, and I'm claiming that the output is X, and if the output is not X, then you could have this cryptographic game, cryptoeconomic game, where you can determine via fraud proofs who's correct and who is not correct. Now, unfortunately, one of the things that TrueBit, I believe, does not have is basically a notion of state. So you can have these isolated statements, but you can't really have like an EVM-like state machine where contracts have a notion of state, and then you can repeatedly update and read the state. And so I think it's maybe a little bit of a missed opportunity so far, or maybe like a feature that they should add in the future to really compete with these other optimistic roll-ups such as Optimism and Arbitrum. So I guess at this point in time, they don't really have the power and expressiveness as these two other projects. Allow me to repeat someone else's question. Thoughts on the future of being a multi-chain world? So my thoughts have evolved here. So on the one hand, I think we will necessarily have a multi-chain world in the sense that chains can do fundamentally different things. So for example, Filecoin is a layer 1, which does something fundamentally different than what Ethereum does. But on the other hand, you have kind of different chains that do very similar things to what Ethereum does. So there's Polkadot, for example, or there's Cardano, or there's Tezos, and like one of the realizations is that I have this notion called ultra scalability. So what does ultra scalability mean? It means that I believe that over the 10, 20, 30 years, we will have enough scalability for a single chain, for example, Ethereum, to support essentially all applications of the Internet of Value. And the reason is that in addition to rollups, which kind of give us this 100x scalability, in addition to sharding, which gives us another 2 or 3 orders of magnitude, we have this other kind of arcane law, which is known as Nielsen's law. So what does Nielsen's law say? It says that the growth of bandwidth increases by 50% every year. Now, if you look at scalability, there's basically 4 resources that could potentially be bottlenecks. There's raw computation, right? Raw CPU cycles. There's storage. There's disk I/O, and there's bandwidth. Now, it turns out for the first 3, we have kind of advanced techniques that can remove these bottlenecks. So, for example, remove the bottleneck at the consensus layer. So, for example, for computation, you can take a SNARK and you can compress all the computation, and all this compression work can be done off-chain, and it only has to be done off-chain by a single party. And then on-chain, you just have to verify the SNARK. And so kind of these consensus level participants don't have to do much computation. And then if you look at disk I/O and at storage, you can use statelessness, so which kind of remove these bottlenecks for the consensus participants. And then you can do a similar thing kind of off-chain. Off-chain you can have these more powerful actors with lots of parallelism and kind of do work that the consensus participants don't have to do. But then there's this fundamental bottleneck, which is bandwidth. Bandwidth is the fundamental bottleneck for consensus, for scaling consensus. But the good news is that bandwidth is the one thing that won't stop scaling. So I started doing some research in bandwidth. I kind of find it fascinating, and bandwidth has been, I think, growing 50% a year for roughly 50 years. And the question is, okay, when does the exponential growth stop, right? Because all exponentials stop. It's just a matter of when. So I started looking in fiber technology, and fiber is amazing because it's a single strand of fiber is roughly the diameter of hair, of human hair, and it turns out that it can support hundreds of terabits, actually close to one petabit per second, a single kind of strand of fiber. So right now around the world, we're making this huge investment, kind of digging up the streets to lay the fiber, and this is very, very expensive. But it's a one-time thing for the next 10, 20 years, maybe even much longer. And the reason is that if you want to update the bandwidth, you don't have to update the fiber. You only have to update the transceivers on either end, and these transceivers are getting better and better and cheaper and cheaper. And just to give you an idea of what's available in production today, so I was talking to this technician who is laying fiber in Cambridge, where I live, and he was telling me that they have a link from Cambridge to London, which is 26 terabits per second on a single pair of fiber. Now, that's like orders of magnitude. Then it's like 4 orders of magnitude more than one gigabit per second connection. That's kind of top of the range for a consumer. So there's really a lot of room for growth for bandwidth. I don't expect this to change. Long story short, you have this ultra scalability, which means that we're going to have tens of millions of transactions per second on Ethereum. And so I do think there's going to be a competitive dynamic with where there's two products that provide basically the same thing. We're not going to be limited by scale. The other interesting kind of observation on this point, and that's kind of my closing observation, is that there's this notion of shared security, right? So and then there's network effects to having shared security. So Ethereum can have shared security on tens of millions of transactions per second. But every time you move to a new domain, you kind of have to pay the cost of a new security assumption. And whenever you have applications which are cross security domains, your final security is going to be the weakest link. And so you really don't want to hop to too many of these security domains. And so that's kind of another reason why there's going to be a natural force, a natural network effects towards having everything on a single security domain, so long as you're not doing something completely different like Filecoin, which Ethereum is not doing. If you could spend all your time on one open research question related to Ethereum development, which would you prioritize? So I guess Ethereum, you can kind of think of it as multiple stacks in the layer, right? So there's layer 0, which is kind of the people, the community. There's layer 1, which is the consensus is extremely technical, and then there's layer 2, which is all the application. And I think each three of these layers are critical. It's hard to prioritize one over the other. The three layers are really, really very important. Now, I've been working on layer 1, I guess, for a long time, over 3 years. And the good news there is that there's not that many open questions. There are some very challenging engineering problems. For example, trying to snarkify the EVM. But it's we understand the roadmap. Vitalik laid it out. It all makes sense, and it's quote just a matter of doing the engineering. There's not that much open research question. In terms of layer 2, that's critical for providing utility overall, and the ecosystem is doing a great job. It's kind of ironic, but I think maybe one of the layers where we could do more work, I guess, is the layer 0. And one of the things that I discovered is that at layer 0, one of the very powerful tools is memes, right? And so I've been thinking about this ultrasound money meme and kind of trying to understand its raw power. And I think there's kind of a lot of low-hanging fruits at layer 0 to have tools that allow us to coordinate better and to unify, to educate faster, and things like that. Does Ethereum plan to conduct an MPC ceremony for the trusted setup to be used with the KZZ commitments? Great question. So I guess we're not going to use KZG commitments for sure. It's possible that we're going to use bulletproofs, which have a different set of trade-offs. But one of the advantages of bulletproofs is that there's no trusted setup. But if we do go with KZG commitments, then yes, we would have to do kind of the so-called powers of Tau. The good news is that for BLS 12381, I believe Filecoin already did this trusted setup, so we'd be able to reuse their work and kind of build upon it, kind of add additional security. Another piece of good news is that the powers of Tau would be relatively small, meaning that every participant could have their participation be done in a browser without and this participation would not take a lot of time. So we'd be able to have thousands, maybe tens of thousands of additional participants to build upon this Filecoin MPC. Is this a scenario you're concerned about? A DeFi construct is legal in a pre-hard fork chain only, but it is illegal in a post-hard fork chain. A DeFi construct could now become a deal breaker for progress, a state level actor. Okay, so I guess, if a DeFi project is truly DeFi, truly decentralized, then it should have some immunity against the legal system, right? It's like, if it's DeFi, for one, it shouldn't live in a specific legal jurisdiction, right? It should be kind of in the cyberspace legal jurisdiction. And if it is truly DeFi, then it should have basic properties like censorship resistance and things like that. So I guess your question is about CeFi. Like, if there's a CeFi project that could block these hard forks. This is interesting because we have a lot of CeFi today. We have USDT and USDC, and even DAI is to an extent very, very, very centralized because it uses so much USD and things, and wrapped Bitcoin and things like that. The good news is that I think a lot of the hard forks are purely technical in the sense that they're very agnostic. It's not like they're opinionated. So hopefully the set of hard forks and upgrades that we'll do will be non-contentious. But one of the things that I suggested in the past was this idea of let's try and have an ETH price oracle at layer 1, and I think one of the reasons why, and that's kind of a little bit opinionated, and I think one of the reasons why it wasn't well received by the community is precisely because it's opinionated. So I realize I have 20 more questions, but only 1 minute. Sarah, how is this going to work, or Itai? Should I wrap up now?
Please take just one more for the minute, and then we're all around in the different forums, Slack, GatherTown, etc., and we can proceed the discussion there.
Okay, fantastic. Yeah, happy to answer questions in this other forum once I have the link. Okay, a tough question. How can we fight Geth and Prism dominance on ETH1 and ETH2? I think Geth is a hard one because it's so enshrined. I think TurboGeth, now renamed to Aragon, is doing some very interesting work, in terms of performance, and I'm hoping that a very significant share of ETH1 nodes will migrate to that. On ETH2, the situation is not so bad because we actually now have 5 validator nodes on ETH2. So the hard work, the hard engineering work has largely been done, and it's not just a matter of adoption. I think one of the things that could be said or that could be argued is that doing the merge with, let's say, 70% or 75% Prism dominance is a little reckless. And so kind of as the kind of research and dev community, we're not comfortable recommending a merge date or kind of a merge schedule until the situation improves. So that's maybe one lever that we have to encourage people to move away from Prism. I think another mechanism, and it's kind of somewhat unfortunate, is that if Prism gets hacked, then people will learn their lesson. Basically, we have these mechanisms whereby the penalties are correlated. So the more correlated failures you have, the larger the penalties. And so if something bad happens with Prism, people are going to pay a very expensive cost. And so, but the upshot of this is that we're going to have more decentralization. So it's kind of this anti-fragile system in that sense. But yeah, I'd much rather that people move away from Prism proactively than have to do it after they've learned that centralization of nodes is bad.
All right, thanks very much, Justin.
Okay.